Okay, hi. It's Monday on 1 o'clock here on the East Coast, and I just wanted to do a little video to introduce some of the themes of week 8 and talk about the assignment a little bit for this week. I find that Mr. Robinson's or Professor Robinson's videos to be really good, um, and so I just want to highlight a couple of things from this week's video. The first is that, as he says, time is really the essential element when doing project management. A couple of weeks back, we had a discussion forum question that talked about, is it scope, is it time, is it resources that are the critical, that is the critical dimension of project management? Well, he clearly states that it's time, because you cannot fudge time. You can't stop the clock. You can't turn it back or forward, whatever. You can adjust the scope and resources either up or down, but time just marches on. And so he makes that point, right, that when you add time dimensions to a to-do list, you then have a real plan, right? Because time is that real critical dimension then that relates all the tasks to one another. All right. Let's see. Then he goes on and talks about um, if you if you introduce time into your to-do list and create the plan, then you have to necessarily think about the order in which tasks need to be performed. And he talks about, what's the word he uses? Come on now. Predecessors, right? Those things that have to be done before you can do a particular task. And he has some nice examples. The book has some nice examples. When I was reading about it, I was thinking about whenever you fix something or make a model, there are typically things that have to be done before other things. For instance, if you're building a model, normally all the pieces come attached to something, and you have to break all the pieces off, and then you can start to assemble them. But you can't obviously start assembling them until you take the pieces off of the material that they're attached to initially. Same thing like when you're fixing a washing machine, right? Normally you have to take the cover off of the washing machine before you can get to the motors where the problem typically is. And so, it takes you a certain amount of time to take the cover off the washing machine. And so that has to happen, and that time has to elapse before you can start actually looking at the broken motor. Okay? So just an example there. The third thing then that he talks about is sort of for each of your tasks in the work breakdown schedule, you have to then think about 4 things. And let me just put this up, right? You have to think about the competencies that are needed in order to do the task. You have to think about the duration of the task. You have to think about predecessors, and so the logical order in which these tasks have to be done. And then he talks about, what resources need to be allocated to each task. Okay, I'm kind of holding this up because I think it's really important that as you do your assignment this week, that you try to figure this out. In assignment 2, you had to essentially talk about the main tasks of your project, right? Now you should list all those down the side, but then start filling out the columns here. And as he says, as Professor Robinson says in his video, we're going to be adding columns as we go along. All right. And I guess what I want to say here too is that in assignment 2, I spent most of my time looking at your need statements and trying to get you to focus there on what seemed to be common deficiencies. I did not take a lot of time, frankly, looking at your task list or your list of tasks. Make sure in this coming assignment that your task gets you from the beginning to the end, meaning the last task should basically be everything done. That very scientific term there. But why I emphasize that is because as I'm thinking back to some of your task lists, they were sort of the things you had to do at the beginning of your project, but not necessarily what you needed to do to complete your project. So in this next assignment, I'm going to look closely at whether your final task actually gets you to completing the project. And if it doesn't, then yeah, I'm going to take off points. But the main point is that you won't get the full experience and the benefit from the exercise. All right. So we've got that. And then yes, after you do this and you have the predecessors here, then it will be possible, and the duration of tasks, it'll be possible for you to actually then do the timeline and the scheduling that is this week's assignment, either in a PERT chart or in that Gantt chart. And, Professor Robertson talks at the beginning of his lecture about how you can use Microsoft Project, or he talks about an open project software. I think as he suggested, you should try these and see how they work for you, see how mechanically they work. But for my purposes, for the assignment this week, simply doing a glorified Excel spreadsheet is fine with me. In terms of using that software to develop your Gantt chart, which I presume most of you will be doing. Okay. The other thing just about the assignment that I want to highlight is that the example there is not complete, meaning there's a column that tells about the tasks, and then there's another column that says resources, but if you read the note below it, it says this is incomplete. So I'm not sure why the example isn't really a complete example, but what you need to do is actually really fill one of these out, and then based upon duration and predecessors, schedule out the tasks on a Gantt chart. Okay? So don't just send me something that looks like the example, because the example says in the fine print it's not complete. Okay? All right. And I guess just the fourth thing that the professor talks about in his video, yes, he talked about the importance of time. He talked about the sequencing of time-sensitive tasks. He then talks about organizing those time-sensitive tasks in a timeline, the Gantt chart. And then the fourth thing he talks about is this notion of simulations in order to get some sense of the certainty or lack of certainty with which you've made your estimates about the time it will take you to do a particular task. And then he has this long discussion about the unknown unknowns. But the main thing here is that, particularly in projects, the very nature of project is that it really is not a routinized effort. And so you're doing things for the first time, or you're doing this combination of things for the first time. So there's uncertainty involved. And so where you might say this thing takes a week, well, what are you basing that on? Have you actually done it before? And if you've done it before, well then, okay, maybe it takes a week. But if you're just kind of guessing by the seat of your pants, you could be way off. Who knows? And the simulations then take into account the uncertainty of all of your estimates of time and resources, and then through simulations and statistics, it gives you probabilities of and ranges of time that you'll actually end up using or taking to do the project. Okay, that's a whole nother statistics course, frankly, but I just thought it was interesting that it was there in the chapter. Okay, all right, so I think that's it for now. Just wanted to make sure that we were clear on the assignment for the week. Okay, and if you have questions, call. If you have questions, ask in the message. I'll be looking there a little later today, and I'll see you online. Okay? All right, thanks.